In the last video, we introduced the concept of the mole. In this video, we are going to look at further calculations between the number of moles and the number of molecules, as well as the number of atoms. Recall that 1 mole is 6.02 times 10 to the 23 particles, which is known as Avogadro's constant with a capital N subscript A. We can formally define the conversion between the number of molecules or particles and the number of moles as follows. Big N is equal to little n times big N subscript A. So big N is the number of molecules or particles, little n is the number of moles, and N subscript A is Avogadro's constant. Now, if you like using triangles to figure out how to convert between different formulas and how to rearrange, our triangle for this relationship would be as follows. So for those who haven't used triangles, what you would do is if you were solving for the number of moles, you would cover up the number of moles. So let's cover that up. We'll just scratch it out. And so that would equal to N, and then the line means divided by Avogadro's constant. If you wanted to solve for the number of molecules, you would cover that up, and that would equal to N times N subscript A. Let's look at some examples then to use this formula. Our first example says if we have 1.5 moles of sodium chloride, how many molecules are there? So for this one, we're solving for the number of molecules, or big N. The formula then we're going to use is big N is equal to little n times Avogadro's constant. So we know little n is number of moles. In this problem, it's given as 1.5 moles. And Avogadro's constant is 6.02 times 10 to the 23. When we do this calculation, you get 9.03 times 10 to the 23, but we want two significant digits, so 9.0 times 10 to the 23 molecules. And that is the number of molecules in 1.5 moles of sodium chloride. Let's try another example then. If you had 5.83 times 10 to the 24 molecules of carbon dioxide, how many moles are there? For this one, we're solving for number of moles, or little n. So that means we need to take the number of molecules and divide it by Avogadro's constant. Plugging in our numbers then, we've got 5.83 times 10 to the 24 molecules. And we're dividing that by 6.02 times 10 to the 23. So when we do that, we want three significant digits in our answer. That gives us 9.68 moles. So that means there are 9.68 moles of carbon dioxide in 5.83 times 10 to the 24 molecules. Sometimes you'll need to convert between the number of atoms and the number of moles. And really all you do here is you figure out the number of molecules from our previous formula, and then you need to count the number of atoms within one molecule. And so you're going to take your number of molecules and multiply it by the number of atoms to get the total number of atoms in that particular substance. So looking at our first example again, it's the same as our previous first example where we had 1.5 moles of sodium chloride. And when we did that calculation, we knew that the number of molecules was 9.03 times 10 to the 23 molecules of sodium chloride. Each sodium chloride, so one molecule, has two atoms because sodium chloride's formula is NaCl. There is one atom of sodium and one atom of chlorine. So the total number of atoms is going to be our number of molecules times 2, or 9.03 times 10 to the 23 multiplied by 2. So that means in this sample we would have 1.8 times 10 to the 24 atoms of sodium and chlorine in 1.5 moles of sodium chloride. That means that 9.0 times 10 to the 23 atoms are sodium, and 9.0 times 10 to the 23 atoms are chlorine atoms. Adding those two up together gives us the total number of atoms. Let's just convert back the other way. So if we have 1.5 times 10 to the 24 atoms of sodium and chloride together, how many moles of sodium chloride are there? So we know if we have 1.5 times 10 to the 24 atoms, to get the number of molecules, we know that each sodium chloride molecule has 2 atoms. So we're going to take our total number of atoms and divide it by 2 to get the total number of molecules. And so in this example, the total number of molecules would be 7.5 times 10 to the 23 molecules. Now that we know the number of molecules, it's pretty easy to convert back to the number of moles because we know we have to take the number of molecules and divide it by Avogadro's constant. So 7.5 times 10 to the 23 molecules divided by 6.02 times 10 to the 23 gives us, two significant digits would be 1.2 moles of sodium chloride. We want 2 sig digs because our question gives us 2 sig digs and all we are doing is multiplying or dividing.